Okay, so going through our bivariate class with Seaborn, and we'll get started. Okay, so going through the red wine data set today, and a common thing, although we're going to do bivariate, still is nice to understand my data in any sense and help me understand what I should be expecting to see. So plotting the univariate relationships just quickly in a loop, 4 feet in df columns, the figure, the histogram, and then making sure I show the plots. Okay, this really just highlights and lets me know kind of what I'm seeing a lot in my relationship. I'm seeing lots of outliers I would expect to see and pay attention to those then, how that might be affecting my bivariate relationship. Okay. Because I don't like the standard, well, I mean, the standard colors are fine. I gotten bored of those, so I like to change the colors a little bit. So I have another palette here, and then which is this, turns out to be this. And so we're gonna go set palette, put the list of the different colors in here. And then what I'm doing in this next line is just so that I could see what colors in my palette are. Maybe I want to change them around a little bit, get them sitting a little bit better. I'm just going to then go sns.color palette and just kind of show those colors right there. And it'll give me a list of the red, green, blue of each one of these colors. So going on from that, then looking at our, starting off with our scatter plot here, do plt.figure, sns.scatterplot, data equals df, x equals volatility, and y equals another continuous variable right here. Okay, so two continuous variables. One of the things that we can do in with the scatter plot, there's not a whole bunch we can do truthfully, and so changing the marker is one of them to square or to triangles. You can also change the size of your values, and you can also change the alpha. Okay. So then reg plot. So not really truly a whole bunch you can do, but you can see even turning down the alpha, it did help. Is it the ideal plot for understanding how much data really is in any given spot? You know, I don't know. I wouldn't really say it becomes a little bit more difficult at this point with this much data. Okay, reg plot. So same thing, x and y in our variables. We're just calling the s and s reg plot this time. And then we can also do things, I think this is a really great practice, doing something a little bit more advanced with Seaborn, and then with your plotting functions and being able to, get good practice with Python. This is changing a sublevel function. So regplot is made up of two other plots. So it's made up of a line plot and a scatter plot. Okay. And so anything that we pass that scatter plot up above, we can then change those options right here. So I'm going to change the color of this, the plot, the scatter, the dots, to one color for my palette, and then changing the color of the line to another color for my palette. Okay. Getting into the KDE plot. So it's a very simple plot. I don't know if it's my favorite, but it works really well in certain situations. Okay, so doing the X and the Y here, we're doing bivariate, and it goes into the KDE plot. And then we're gonna go change the quality, the hue by a continuous variable, right? And so we can see, you can start to see, even with this many, you can really start to see, okay, the higher colors are over here, the lower colors are down over here. It's a little bit busy, but you get the sense of that. And I think a better way would be to use a category that's a little bit more simple than a continuous variable like this. So we're doing here quality. I'm going to break it down in just low and high and remove kind of the continuous aspect of this variable, just now making it two categories, high and low. And you see when you plot those two, using those as the hue, you guys are able to really understand where those densities are, right? So this is simple. We want to make sure not to clutter it as well, but it would be hard to see something like this in a scatter plot because the dots would just be so much on top of each other, and you wouldn't really understand that over here is really where the density of one bivariate, the bivariate by the category is, okay? And so the category here for this bivariate relationship is way over here, and so you're getting a sense that this relationship, alcohol and volatile acidity, has something really important to do with our target, and maybe it gives us a sense of what we could engineer for machine learning, what we'd want to pay attention to in this plot as well. Okay, joint plot here, going into same way that we use it, we're using the joint plot now, we're going to use X and Y here, and you can see that it's doing the two variables right here, and doing the univariate axis on one and univariate axis of the other, and then plotting that. So you can, even before we do anything else with this plot, you can start to get a sense of, well, here's the highest histogram here, here's the highest histogram here. Okay, so I think my highest weight of my data is actually right here. You wouldn't be able to see this in another way, but it's somewhere right here. Okay, so let's just get a better understanding of this. Okay, we can use the hex plot, which is a beautiful plot, and give us the same thing as a two-dimensional histogram would give us, in the sense that the colors are coding how much density is in any given spot. Okay, so the darker the color, the more data we're actually seeing at this point. Okay, and then we're going down here. We can also do the KDE plot right in this as well, using kind equals KDE and kind equals hex here to do the hex plot. And then we can add, when we do the KDE, we can change the hue argument. You can't do this one with the hex. So with the hex, you can't use the hue argument, which is too bad. I think it would look really cool, but it doesn't work. And so here you can see, really getting a sense of, again, the univariate on either side, and really you can see it's much more affected by this. Alcohol has a lot more interaction with the low category versus the other one here. So making some comparisons about between the bivariate relationship, which is maybe impacting our category more, which is the one that we want to pay attention to more. Okay, and having some fun with this as well. Doing a similar thing that we do, we passed arguments to a sub function. So in the joint, we're doing a hex plot. In the marginal, we're doing a histogram. Okay, so here I'm going to say in the joint, do bins for, in marginal bins, KD equals true and line width equals 3. Okay, so you're doing the histogram here, adding a KD plot to this, and then changing the hex bin to only say I only want to have 4 bins. For hex plot, the bins are the shades of color, right? So white, light, medium, and dark are 4 levels of plots, right? And so it kind of just gives you very generalized where the data is, and really, oh, here's the most important part. We can go the other way, and you could do something like 40 colors, and really showing all of the detail in our hex bin, right? Going from the lowest to the highest, and really visualizing this in quite well. And also in the histogram, I'm going to go fill equals false and line width LW equals 3 to make them a little bit thicker, but make sure there's nothing on the inside as well. So many things that you can do to get the desired effect and really to assist in your data analysis. Okay. Going into the heat plot. So the heat plot, we most often put a correlation matrix, which has the fixed acidity by fixed acidity correlation is 1, and then all the way down the diagonal then is where we have the relationship with itself, which is always 1, right? Correlation with yourself, and then we can measure the fixed acidity with volatile acidity, negative 0.25, citric acid 0.67, residual sugar 0.11. So really, getting a sense of all these. You could go through all of this like this if you want to. It's a little bit busy, so we can put it into a correlation matrix, and so you just go sns.df.heatmap df.core and sign that. I think a way that I prefer to use it is turning up the line width. You get a little bit of spacing in between, and then I think as well putting it on a figure here, making it a little bit bigger for us to plot can be really helpful. I also think it's really important to note this and making sure that we're displaying the actual correlations here. It can be a little hard to see and understand, okay, yeah, this one's bigger than this one, or wait, which one's bigger, right? These both are darker here. It's kind of hard to see at this point which one is more negative, right? And so, and we can see they're actually 14% different, right? So it's quite a big difference, right? So we want to be able to understand that a little bit better. The colors are great, and they guide our eye to where to see, but we need the numbers to kind of finally decide, what's stronger, what's really worth investigating. Okay. I don't like the standard colors of Seaborn. I just say they're not my favorite. So then I do the crest plot normally, and it makes it nice. I like this color palette too. If I wanted to do a little bit something a little bit different, I could do the light palette here, and it would show the just putting a color that I've gotten from colormine.io. Lots of good colors there. It's an AI color generator, and so it seems to know what I like. And so just here, this is great. The light palette is great for when you have one direction of colors. And because we have positive and negatives, we can actually do the diverging palette. We're giving two different integers from 0 to 360, and the center is light here, so we can see we get nice different colors and really highlight which is negative and which is positive in our data set very quickly and easily. Okay? And get a really sense, okay, now we can really focus, okay, let's really start to understand these really higher correlations right here and kind of ignore all the stuff, that's not really super important. Okay. To kind of assist in understanding these correlations, we can use SNS.PairPlot and very quickly visualize many of our bivariate relationships in our data sets. And so the one thing about this is you don't want to be looking at and analyzing everything in detail. You want to kind of step back and look and see where my eye is drawn to, right? Okay, so I see a little bit of a correlation here, here. Curious to understand why fixed acidity has these two correlations, are very highly correlated or more so correlated with these two ones. Maybe understanding what's going on, why there seem to be outliers on this side right here caused by chlorides. And this gives you a higher, level to go and understand which ones do I really want to explore. Maybe this one right here would be good as well, and understanding those relationships. But now I don't have to go visualize all of these. I can just, happy with what I did, and I can go a little bit deeper. We can also put a his plot into this and look at a two-dimensional his plot, which is very similar to the KDE plot. In the darker the color represents, the higher the density of supporting this trend. So, this trend, these two trends, they look like a good relationship across the board. You can actually see there's only a little bit of data, or most of the data isn't really the center of this. There's not this whole, that looks like a line here that supports this. It's not really, there's really not a lot of data outside of this little center range right here. Okay. It'd be kind of, yeah, is this maybe worth exploring then? It's one of those things that we need to think about. If we have enough time, maybe yes. If we don't, maybe no. Okay. Here we have a corner equals true, just to turn off the duplicated side if you didn't want to see that. We can also do diag kind, and we're going to put diag kind equals KDE, and look at the KDE on the diagonal. Just kind of showing lots of different options. As we work well, if we're going to do the hue equals category, and plotting then a reg, kind equals reg, and KDE on diagonal. So those are good, and there's a lot of options with the PairPlot. I really like the PairGrid if I'm going to do this. For lots of different options, we have lots of flexibility in this. Okay, so we're going to do SNS PairGrid, g.diag, map diag, KDE, regplot, and hisplot as we go through this and start to understand and explore this relationships. Okay, really gives us a good sense of, here we're looking at a histogram down on the left-hand side. Really, we can see where the density is supporting then this regression line here. So we see this regression line here. You really see actually really not a lot of data supporting that whole line. It's all right down here at the bottom, right here. There's not really a lot of data up here. And so is that linear relationship really worth investigating if most of the data isn't there to support it? Another thing that we can do is hisplot, KDE, and LMPlot, and just showing it, turning down the alpha, just to be able to better visualize the categorical relationships with the data. And then one of my favorite ways to use this is the swarm plot with the resid plot with the reg plot. Okay, so swarm on the diagonal, resid plot on the upper, and regression plot, reg plot on the lower. Okay, and the way that, just to highlight this, the way that I am passing then arguments to resid plot is not going to be resid plot. It doesn't have the parentheses after this. And so what's actually happening is we're referencing this plot, and then map upper is going to take control of this, take responsibility of using this. And so in that, we're going to go scatter plot KWS. We're not going to give this to reg plot. We're giving this to the map upper. and it's going to take responsibility of passing these arguments. You can see the size of the dots here in the swarm plot is we're passing that argument to the map diag and not to the swarm plot. And map diag will take responsibility of taking control of that function and then how to use it, and then it will pass that argument to it. Okay. Same thing here with the scatter plots, turning down the scatter portions of the reg and the residual plots, and then the size of both those variables. We get a cool, really cool effect in this. And you can see here, swarm down the side, you really get a lot of detail when you do this in the swarm. It just really gives you a lot of detail. And you really see, it's interesting how this one variable, citric acid, by itself, we're looking at that, has a lot of truncated. All the other elements seem to be very uniform in their densities across the univariate densities. Kind of interesting to understand that a little bit better. And that could have something to do with when you look at these relationships, the citric acid with the fixed acidity right here is not really, it looks like a good relationship right here. It looks like we did a good regression line, but when you look at the residual, actually I'm seeing a little bit of spreading out here, which is called heteroscedasticity. But it looks like there's a little bit of a pattern, and you're also noticing here that orange is more on the upper side and green is more on the down side. And so we seem to be missing the orange a lot more. Why would that be? Is that related to this univariate, this detail in the univariate relationship here? We're seeing a lot of density, 1 point right here on the higher end of this univariate value. Okay, this is kind of interesting and worth, you can spend a lot of time getting lost in that and just explore a little bit more. Okay, getting into some of the figure level plots. Okay, so making a couple other categories here, just have more categories to play around with the colors. So making one for volatile acidity category, medium, high, low, and making one for alcohol. Just to highlight here what was happening is I'm putting bins or the outside edges. So I'm going to have one more outside edge number of bins, so low, medium, and high as well for the alcohol category as well. Okay, so getting into the rel plot, we're seeing free sulfur dioxide, total sulfur dioxide, kind equals line, and then row equals category. So we're going to do the alcohol category for each one and really just understanding how this linear relationship, this line plot is different between those two. And also do scatter plot here, changing that, turn down the alpha, and really start to see if we can plot that bivariate relationship by the different levels of alcohol, right? Now broken up by that. Change the size here by the quality to highlight, and this would be maybe the target, the likely target in our data analysis in this use case. And so now we're able to change the color by another category as well, which is a little bit interesting. This is the only plot that this is available in, so it's kind of interesting that we're able to do it. We don't have many on this end of this variable, so that's probably why we're not able to see so much, but it is nice that we're able to, you have that feature available, and you could probably find a better plot that would work with. Okay, the LMPlot is the linear model plot. So just the same thing. So X and Y, if you wanted to, you can also then change the row and add in a row argument to this. So just focusing on the bivariate relationship here, we can do the CE confidence interval. How do we want to understand this confidence interval? And so we're saying 99%, so it would be a little bit wider where we can make sure we're going to be 95% sure that our regression line is going to be somewhere in between these plots. Another cool feature is we can turn up the order, and so to do a second order regression line and really understand that curve, I find second orders really highlight the linear, like how outliers are affecting your distributions. And so I think it's really important to understand and can be a little bit, or certain affecting our linear relationships. So we'll watch those correlations and we turn up the order. Okay, one of the many things we can look at here. I'm going changing because this is a figure level, the way you change the size of these plots is you're going to go height and aspect. An aspect is just saying how many times the height do I want this to be. So it's a little bit wider here because my height is 4 and then 5% more than that on the aspect. Okay, and you can see with the higher order here, really highlighting where those correlations are kind of out of whack and stuff here. Okay, you can do then row and column here, and by two different categories, and really start to separate by the subcategory: volatile, like acidity low, alcohol low here. Very tight linear relationship when that happens. It doesn't hold true for all of these categories. You can see total sulfur dioxide when it's the medium category and the low alcohol, it seems to really not that straight tight line that we saw up here. Kind of pulls down. Again, could be these outliers over here, but really not holding that tight linear relationship anymore. Okay, and another cool feature here, changing the quality, the hue by the quality category. Really plays around, get some sense of how that sub category is allowing you, affecting those relationships. Okay, so and then just having a little bit of fun with this, I'm going to pass the line KWS and the scatter KWS, just like we saw in the reg plot. I'm going to change the line width of the line, making it a thicker line. I'm going to change the size of the scatter and turn down the alpha. Okay. We cannot do the changing the size by the another category in this one. That was only working in the rel plot. It's just different features, whereas the order is something that we would have available in the linear model plot. Okay, so really, depending on, do we want to focus on relationships or do we want to focus on the linear model or the linear relationship in this sense? Okay, and just I think you got a really cool effect from here, and you're really seeing how those outliers are really pulling this order, the third order regression line, in different directions, and really kind of highlighting it's not maybe as, except in one of the categories, it's not such a great linear relationship anymore. Okay. Moving on from that, making another category here, and then going into the diverging plot. So this allows you to kind of go through and choose a good linear model plot here. So if you do the SNS diverging palette, or sorry, and it's a good colors to choose for your representing your positive and your negative correlations. So this goes from numbers 0 to 360. And there's a way that we can actually choose that. We'll see that here. Light is 65, center light, CMAP true, and 9 is the different colors. So we're going to see 9 different colors here. CMAP equals false. So when CMAP's true, it goes continuous, and when it's false, it's going to do more of a kind of jaggedy line. Okay. I honestly find I have to kind of play around with it, but most any random number between 0 and 360 together really tends to work quite well. Okay. If we're not sure though, what we can do is we can use this SNS diverging palette algorithm to see how our plots look. And so what we can do is we can play around with this negative. Oh, okay. No, those don't really go too well together. I'm going to put this down and get two different colors and really help me choose which colors make the most sense. S is the saturation, so if I turn that down, you'll see that it gets kind of not a lot of color, quite big. And if you turn it up, it goes kind of brighter color. Light is how, or L is how light you want your plot to be. Do you want it to be very light or very dark? Okay. Kind of either side of those. So we're in the middle would make more sense. Okay. And then we also have separation. So sep is how much white color there is in the middle. So if you do turn this up, you're going to see you get more white in the middle. Okay. And then N is the number of colors, and you could change it even to a dark palette as well. Okay, so the center is dark instead of light. Lots of different options there. I played around and I found these two to be the ones that I liked. And I'm just going to put this in the CMap of my heat map and now have a nice custom made color palette for this. Okay. We could also do dark palettes, giving it a red, green, blue set of colors here, and then changing the CMap to a node equals true. CMap palette that I just created up above, and you get the dark palette, and you also get the light palette here. Okay, and really, which one I find the light palette is a lot more valuable in most situations. I think just going from a light color to the color that you've chosen makes a lot more sense, but then going from a dark color to the color you've chosen, whichever you prefer. I think this is really handy as well because you can actually just choose a color combination and put it in here, just the string that represents it as the first color instead of these red, green, blue, the three colors here. So it can be a little bit more handy in choose customizing your plot for some given situation. Okay. So thank you so much for joining me today, and I will see you for class 7.